Cool evening, everybody. Good evening. So, it's so cold outside. So, current temperature is okay, -1 degree centigrade. Okay, 31 Fahrenheit. Okay, so let us start. And what do you want? We're gonna finish early so that we can go home safely. So let us look at our schedule first. Okay, so according to our schedule, your test 3 will be in your next class, right? Your next lecture will be test 3. So test 3 we will cover content from week 7 to 10. So on week 7 we discuss reference parameter. Okay, so reference parameter is applicable although for C#, but you will get question. So everybody needs to answer it, even if you are taking Java lab, no matter. Okay. And then you will have recursion, linked list, tag, and QE. Okay, so again I mentioned that this year that question will not be as usual for last year, previous questions. Okay, you need to study and practice. Okay, for your recursive parameter, I discussed some questions, some example live programs. Follow those programs and practice. And for recursion, like for instance recursion process fundamentals, and for instance some problem solving like reverse string recursively, okay, or find the length of a string recursively. Okay, practice this. And for linked list, tag, and QE question, for linked list, push, okay, append and prepend method and search method discussed, right? Find method or search method. And stack, and for stack, push, pop, and pick operations. And for QE, NQ and JQ operations, right? So this is the methods. Okay, practice all of these methods. Okay, A to G. Okay, you might not be given the structure or format of the method. You have to write everything, whole format of the method. Okay, so please practice. Without practicing, you will not be able to do well. So anyone has any question? Okay, Patrick. So if you have a Patrick, so please share your project. Patrick, you can collaborate. You can add me. That means CSITEd experts as a collaborator to your project. If it is in GitHub, or you please send me the entire project, not the code snippet or part. Okay, the entire project. Okay, then if you share me that, if you have an issue, I will reply you. Okay. Anyone has any question about the upcoming test? Okay, I like everybody. There will be 45 minutes. I have never seen that anybody was out of time. So I like everybody to read the question carefully. Okay, next time please do not do mistake that, oh, I did not carefully read this. Okay, please. Anyone has any question about test? Okay, that is good. We are almost at the end. So maybe we will get one more week before the Thanksgiving, right? Before Thanksgiving, Thanksgiving break, we will get one more week. So this week we are discussing threads and parallel processing, and next week we will discuss binary search tree. Okay, that's it. and after the break we will discuss. We will get only 1 week. We will discuss. We will review. Okay. So in our last lecture, I discussed threads and multi-threading programming. I discussed with some live programs with Java, right? Let me see what I discussed. Okay, thread is the execution path of a program. A program may have multiple execution paths, but so far whatever the program, sample programs we discussed previously, all of the programs were single threaded program. But it is possible to create multi-threads so that we can execute some processes or some functions or methods parallelly. We are discussing about single processor, using single processor. Then in that case the processor will share or slice the time. Okay, but actually multi-threaded program, that kind of programs, a program with multiple threads or execution path is called multi-threading, multi-threaded program. So the process is called multi-threading. Okay. So we discussed that in Java there are 2 ways to create a thread. By the way, Java, in simple Java programs have the main thread that contains the main method. Okay, and there are 2 ways to create a thread we discussed: by extending the thread class or by implementing the runnable interface. Okay, so whatever we do, we implement. So this is a way that we discuss, just by extending the thread class. So that when we extend the thread class has a method, run method, that needs to be overridden. So when we override that method, whatever we need to implement within that method, we can call another method, another function within this run method. And finally, in the main method, what we do, we create an object of this thread class, and we create the start method. Start method actually calls the run method. So run method is not called explicitly. Okay, run method is called by the start method. So this is, even in your program, if you are asked to write a code to call the run method, okay, you cannot write thread.th.run here. That is a common mistake. Okay, be careful if you get a question like this in your test. So never call the run method directly. Okay, you will call the start method, and start method will call the run method. This is one way to create a thread, by extending the thread class. There is another way that we can implement the runnable interface. So runnable is an interface, so we need to implement keyword. And so then again, runnable interface has the run method. We need to override the run method. And here it is different. The strategy is different here. Once we implement the runnable interface, then we need to create an object of this class, and we need to pass that object to the thread constructor, and we will get the thread object, and we will use that thread object to call the start method, and start method will call the run method. Okay, so this was what I discussed in our last lecture, and I discussed with some live programs. And so we discussed the thread have mainly 5 states. in its life cycle. So newborn thread, runnable thread, running thread, block thread, and dead thread. These names are actually pretty simple, and these names infer their status or their functionalities. I wish I could make this larger in future. Sorry, I don't want to make this larger. Okay, sorry. And there are some methods developed built in the thread class that are used to actually to control threads. Okay, like we know the run start method, run methods. There are also methods sleep, yield, join. Okay, and this is just a picture of thread synchronization. You will learn more about thread synchronization in your next course, advanced level course, if you take parallel processing course. Okay, but in my GitHub account there are some programs I added if you can practice, want to practice. Okay, so let me open the my GitHub account. So if you go to my GitHub account, 1322. Okay, so I have two main accounts, 1322 review Java _ C#. So in my both projects I do have some programs about threading and multi-threading. Okay, what is the threading one? Okay, I'm sorry, maybe not here. I will add the threaded program here. Maybe tomorrow I will add those, or by the weekend I will add threading programs here. But in my C# project I should have something. Okay, so multi-threading example 1, managing thread example 1, these two, and I should have thread synchronization example 1 and thread synchronization example 2. So I have some programs in C#. Okay, so please get the code from here and practice. Okay, I also added some programs, multi-threading programs on my Replit account. Let me see if I get it. Okay, so these are the C# programs. In our previous lecture I discussed Java programs. Okay, and these are the C#. So multi-threading example 1, thread synchronization example 1, thread synchronization example 2. I should have multi-thread example 2. Okay, managing thread example in C#. This one. Okay, actually these are the same programs I copied and pasted from my GitHub. Okay, let me do a quick review. So here are my main class, and in my main class So called this is the like method called call to child thread. Okay. Okay, by the way, C# has something a little bit different strategy for multi-threading. It's exactly not exactly same as Java. So in C#, let us see this program. So there is a class, built-in class called thread start. Okay, so we can use this class in order to create a thread. Okay, so and when this thread start classes constructor, we call, you see that this one another method, like this is, you see that the difference in how do we call this method. Usually we call a method with its, I'm sorry, usually we call a method with the parenthesis, right? My method name with parenthesis. Okay, so, but it does not work this way for multi-threading program in C# is that does not work that way. So you will not get the parenthesis here. Okay, and so whatever like object I create over here, so this process is more similar in C# Java, that we implement the runnable interface to create a thread. So like same thing, we will use this object and we will pass this object to the constructor of the thread class in C#. So this is my child thread, the thread object child thread equal to new thread, and whatever I create this object, I will pass this object as a parameter. And then this is my child thread, whatever name I gave, so then I will call the start method. But in C# we see that start method S is in uppercase and Java S is in lowercase, right? And by the way, this thread class is for C#, but similar like in Java has its own thread class. You don't need to know how they are implemented actually yet. The classes how they are implemented, just we need to know how we will call them. Okay, this is one example. If we run this program, it should work. Okay, just we call this method and see that the effect of this method is that call that it will execute this line, child thread started. I'm sorry, this is here child thread start. Okay, and one thing while I was programming this one, I realized that usually for other programs I used to give this statement. I used to give this statement just right after here. Okay, within main statement, main method, to show me this message, press any key to exit. Okay, then I use in C# we use console.read key method. Just this key method, this waits until we press any key. So for other programs you will see that I used to give, I'm a fan to use this way. But if I see that there is something interesting, if I give this way, you see that what happens, this statement is executing here, That means, and after that it is executing the child thread start. So that means actually what happens here at this point, program's controls jump to the another thread, this thread. Okay, and even if I give another statement over here, for instance, if I give another statement like over here, so let us see the interest. Still this code will be executing here. Okay, these two lines will be executing here, and then this line will be executing here. So the interesting thing is that when I go to my, if it is not a threaded program, okay, what would happen? So when you call this method, if it is a regular method, if start was a regular method, not a multi-threaded method, then my control at this point, my control would call this method, and it would display this. After that, it would come back to here, right? After that, it would come back to here, but it does not work that way. Okay, so that the thing is that when it goes to the child thread or another execution path, it stays over there until we revoke that. Okay, so now if I run this, so here that means at this point, okay, at this point my control is going over here, and then it is executing this statement, and these are the statements. So one of the examples is here, and then I have another example that I added here. Okay, almost same program, but this program has a use of sleep, the sleep method. We usually use sleep method to make some weight, to give some weight in the program execution. Sometimes we may need to wait. That's how the clock program is developed. So you need to wait in order to change a second, we need to wait for certain time, right? Then wait for another certain times to go another one, then by this time it goes to modulo 60 to make, and the second 59, then instead of 60 it goes 1, it goes 0, and then 1, like this way. So sleep method is used here. It uses second wait time in millisecond. So here we say that if we give 1000 millisecond, okay, whatever sleep for the time over here, if I divided by 1000, then we will give in second, right? 1000 millisecond equal to 1 second. So if I gave like sleep for this time, okay, and then if we divide it by 1000, then it will give us that many seconds. So if we run this program, it will pause this program for 10 seconds. Okay, when I run this program, someone counts 1, 2, 3. Okay, so let us see that it waits for 10 seconds. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, slow. Okay, it got it. Okay, so these are the tiny programs you may practice for now, but when you take parallel programming course, you will learn in depth about this. This should be a startup for you. Okay, and then I have some thread synchronization, okay, program. Mainly it has sleep, and then okay, here run method, I practiced this program long time ago, so I cannot remember what exactly it does. Okay, so let me see if I run it then remember. Okay, that's it. One thing that I like you to remember that when we create multiple threads, okay, there is no straightforward rule that which state will be called first and then which state will be next and then which state will be which thread will be next. Okay, you see that in this program execution sometime it call the child 0 thread, then it call the main thread, then it call main thread 0, then it call main thread 1, then child thread 1, main 2 and 0. There is no specific order that this will call, and even if I run this program next time we will get a different order. Although our code are same, our codes are same for this, okay, but for every time it is calling differently, different thread. Okay, and what is the next one? Okay, one of the use one of the major use of multi-threading program is that in banking application development or financial application development, like for instance, if you have some money if I have some money in my account and if I try to withdraw some money from think about it from a bank account or in an ATM card, okay, and if I tell my wife or someone else, okay, this is my code, okay, this is the passcode used, let us do some fraud activities, like let us transfer this money, same money or parallel time simultaneously from two places, different places, okay. The program will not allow us to do that, because what happens, when you take database course, you will learn that how databases are updated. Databases are updated in milliseconds time, and once a database file is taken, controlled by a thread, okay, it holds the execution of a file or a database is called tuple until it releases its execution. No one's will be able to make same operation on the same record. So that will not allow us to do the simultaneous operation, parallel operation, or same kind of operation from two accounts, from a account by two users or two paths. Okay, so if you take advanced level course on parallel processing, I think this will be your foundation knowledge. Okay, so I don't have anything to discuss about this, so please practice this. Our book have some more information, then our slides have some information. If you go through this, then you will learn some basic idea. Anyone has any question so far? Okay, and then if you don't have question, how many minutes I do have? Okay, let us see what is our next slides. Okay, our next slide is, we have two slides for parallel processing. Okay, since we will miss this week was dedicated for our threads and parallel processing, since we will miss our next lecture, so I want to cover the first slide of parallel processing tonight, and so that in our next week we can finish the next slide of parallel processing and then the BST, nonlinear data structure. So okay, only a few slides. Okay, parallel processing, actually the concept of parallel processing came from the concept of multi-threaded programming. Okay, we discussed the multi-threaded program. In multi-threaded program, more than one thread can be executed parallelly. Okay, it can be executed in one single processor, or it can be executed over multiple processors. So in our like nowadays, all of the computers have multiple processors. If you go to the computer configuration, then you will see the processor, there are co-processors, maybe one or two co-processors. Okay, even there is one single processor, the single processor, most of the operating systems allow to do parallel processing, to execute a task parallelly. How a program can do that? And the operating system controls that. Operating system, what it does, the operating systems, like what it divides the execution time in small slides, and it gives away the little portion of its execution time or strength to multiple processes. So a process is a small program. It can be a complete program or a part of a program. Okay. So the concept of parallel processing is mainly for with parallel processor. Program will multiple program will be running one multiple processors. Okay, so when you study parallel processing, you will hear the word, there is a formula, great mathematician, his name was Moore. You will hear Moore's law. Moore's law is just a prediction. The prediction was maybe given near about 50 years ago. Not 50, 60, you know, this 40, nearly 55 years ago. Okay, so Moore, as a mathematician, he predicted that. Okay, that is a good prediction. Okay, he predicted that. Here is the prediction. In every 2 years, the number of transistor, you know, the transistor was the old kind of resistor that are used to develop electronics devices. Okay, so the number of transistors capacity, the number of transistor capacity would be double per square inches integrated circuit every 2 years. Okay, like about 55 years ago, Moore predicted that the capacity of transistor would be double within every 2 years, and at that time he thought that development would continue for the then 10 years. But still it is 50 years, but still you see that prediction is valid. We just realized that, you know, so that a few years ago we had maybe 4 gigabyte RAM, right? 1 gigabyte RAM, then it makes double, it got double, 2 gigabytes RAM chip capacity, right? Then 4 gigabyte, then 8 gigabytes, 16 gigabyte, 32 gigabytes is doubling, right? And see that how even the small cell phone's capacity, memory capacity is increasing, right? From 2 gigabyte to 4 gigabyte to 8 gigabyte to 32 gigabyte to 1 terabyte, and who knows why it will stop. So that is the prediction of Moore's law. Okay. So Moore's law was just a prediction how the processors will be upgraded in terms of speed, and the memory slice will be updated in terms of capacity. Okay, so actually computer engineers, hardware and electronic engineers, they do more research on this law and on this study. Okay, so we are not going to do more in depth, but okay, so please read these slides and get some information about Moore's prediction. So we want to just focus on parallel processing. So our concept is that parallel processing is a form of computing in which many operations, that mean, are carried out simultaneously. That means many processors or programs will be executed simultaneously. So many workstation and personal computers now have two or more processors that allows to do parallel computing or parallel processing. So that advantage, we know that parallel computing is our execution become faster, and then nowadays we can, even in our small computer, we can execute multiple programs, right? We can watch movies parallelly, we can browse internet, and we can listen something else, and parallelly our another programs can be executed parallelly. So we are used to do multiple activities simultaneously, parallelly, right? So these are the actually the blaze of these are the blazing of parallel computing. Let me see how many slides are there. So this slide, it talks about the parallel library in C#. In most languages, like we are discussing C# and Java. C# and Java have, we know that a little bit different concepts of threading and multi-threading and parallel processing. So as we discussed, the parallel processing multi-threading programs in both C# and Java languages. So those will be our foundation to discuss parallel programming. Okay, so these slides do not have real programs, okay, but I have some real programs in my slides. So let me see, what do I have? I have maybe another GitHub repository. Let me see if I get my program. Otherwise, I have good programs. Anyone knows how can I enlarge font on the left side? I know how to do the font size larger or smaller on right side, but how about on this side, this panel? Anyone know? How can I make larger font on the left panel? I wish I could make
You hit Command comma to open the app preferences.
Command comma.
Yeah, Command comma.
Okay.
And
Then
it's under General Appearance.
under
And then very top, I think General.
general.
And
Then what?
Appearance.
Appearance.
And I think colors and fonts.
Colors and fonts.
And one says basic. Yeah, the top basic.
Basic.
I think if you just, and then text font. Scroll down. There it is. And then it's set to 30, so try hitting edit.
Hmm?
Edit at the top.
Edit.
And that's already 30 points.
So I think the text font are on the right side, right panel. You can already do that by pressing command plus sign.
Yeah.
But I'm talking about the left panel. Okay, so if you can know that, please do a research, okay? If you just know that, then let me know, please. Maybe there is an option somewhere.
It would probably have to be in the macOS system settings to just make everything bigger.
Okay, I will try later. So you have MacBook, right? You use Mac. And if you try it, okay, so let me know later, okay? So let me finish it. I have.
I don't know if there's a way to change it, actually. You can make the whole resolution smaller.
I want
or
to
the,
bigger.
Like, entire display. And
No,
then,
I want to make bigger, not smaller.
No, I mean if you made the display resolution smaller, it would blow up everything on the screen and be bigger. But I don't know if there's a way to change the font size itself.
Okay. Okay, I have actually a program for parallel processing, a good program. Then, actually, during my interview time here, I gave this presentation for this one my presentation slide, parallel programming with Java. So I have a slide. I should have on. Okay, for join parallel processing. Okay, so if you clone my this project and if you import that one, import existing program to workspace, browse, and fork join pp. Okay, this is a program with parallel program with Java that I maybe discuss with C Sharp with Java. Maybe not today or in our next lecture. But I need at least 30 minutes to discuss this. This is a good program that has, if we run this program, we need to run it to, not in this way, we need to run it using a command prompt. This is a command line program. Maybe so far in all Java program, you see that we used for our main program we used an argument, string type argument, right? String args. So in this program, this will be a good example to see how we can write our program that we can execute on command line. So this program will not run on using natural way, this way. So it has command line arguments. So in our next lecture, we will discuss this. Let me test it if it runs. In our next lecture, we'll discuss. I need 30 minutes to discuss this. So Java has a fork join pool that is the latest technology to implement parallel programming in Java. Maybe C# has his own technology, but I want to discuss with Java. Maybe in next lecture we will discuss how parallel programming is implemented in Java. Okay, then if I can, then I will do similar program in C#. Okay. So hopefully by the next week we will cover everything, and let's see. By next week, if we cover everything, so if we cover parallel processing and binary search, BST, we need one lecture. One lecture should be fine to discuss BST. Then after Thanksgiving break, we will review the whole content. Okay. So anyone has any question about test, upcoming test 3? Okay. I wish everybody will do in test 3, okay? Okay, thank you so much everybody, and let us drive safely, okay? The weather is bad, I'm worried. Okay, thank you so much. Patrick, do you have a program? Can I see it right now? Or who can help you?